We are going to put this all together and start graphing systems of linear inequalities. And we have 3 steps for finding the feasible region of a system of inequalities. Step 1 is graph each inequality and lightly shade the solution set, or the half plane where the solutions occur. Next, darken the overlapping shaded regions, which will show you the feasible region. And last but not least, find or locate the vertices, or the corners of your feasible region. All right, let's see if I have a straight edge around here. I do. The area where the inequalities overlap is called the feasible region. Oh my gosh, I'm throwing pens around here. So the feasible region is where the overlap is going to be. So example number 1, graph the system of inequalities, shade the feasible region, and identify the vertices of the feasible region. Now, because I'm working in pen, I am not going to do shading until the very end. I'm going to use arrows instead of shading. And I see that I have y is equal to 3 would be the equation. Y is less than 3 though. Well, my y values equal 3. Remember, y equal equations are horizontal lines. And y is less than 3. That's when the values get smaller, so that shading would go downward. Now my other line, x plus y is equal to 1, or I'm pretending like it's equal to 1 for just a second. So x plus y is equal to 1. If I plug in 0 for x, I have a y value of 1. If I plug in 0 for y, I get an x value of 1. That's kind of a nice one. And when I make my line, I want to make sure there's an equal sign there, so it is going to be a solid line. Let's see if I can get that slope in there pretty equally. Alright, so there's that line. Now, which half plane am I going to shade? Well, if I plugged in the point 0, 0 here, 0 plus 0 is 0. Is 0 less than or equal to 1? The answer is yes. So that shading would go downward. Now, my final answer, and where I want to do the darken, the overlapping shading, is where these arrows overlap. So it looks like, ooh, and it looks like I'm going to have a vertex right there. So I have kind of a triangular region, but then it goes horizontal, kind of boxy right there. And that goes on forever, so it looks like the only vertex I need to find is that one, and that appears to be at -2, 3. So this shaded area is called my feasible region. And that is showing where all the solutions for both of these inequalities are at. Not on this line, but they could be along this line. So kind of an interesting dotted line and solid line there. All right, now my next inequality system has, these ones are very common. X is greater than or equal to 0, and y is greater than or equal to 0. Well, x is greater than or equal to 0. Oh my gosh, that totally did not even make a line. X is greater than or equal to 0 is actually a vertical line. This is x is equal to 0, and x is greater than 0 going to the right. Y equals 0 is actually a line on my x-axis, and y is greater than 0 going upward. So basically, right now, I'm in quadrant 1. And this line is going to be the clincher in this drawing. So if I plug in, now again, I'm going to pretend like that's an equal sign. If I plug in a 0 for x, I get 10 divided by 3, which is 3 1/3. So I have a point at 1, 2, I'm going to guesstimate 3 1/3 right there. If I plug in a 0 for y, 5 times what is 10? Oh, that's a nicer number. And there is an equal sign there, so I am going to make a solid line. And then because it says less than or equal to, I'm going to guess that the shading is going to be below that line, but I'm going to do a quick test point. If I plug in 0 here and 0 here, 0 plus 0 is 0. 0 is less than or equal to 10 is true. So it looks like all my shading was up here in the first quadrant. My feasible region seems to be in this cute little triangular area. Well, I have a vertex at the origin. Looks like I have a vertex at the point 2, 0. And then I have one up here at 0, 3 1/3. And apparently you can't see that because I didn't push that up. So that would be my feasible region, that cute little triangle, and those are the vertices for that. All right, last example is asking us to graph. Looks like it's a little more complicated than normal, and identify the feasible region, blah, 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 blah. Now, obviously, we can use Desmos to help us out with these, but you would then have to transfer them onto your paper. So what I would ask that you do is label your lines when you do use Desmos. So I don't know that you're going to be able